So I think we're live. Both Kasey and I are here to answer any and all questions that you have about Databricks machine learning. We'll start with short introductions while we're waiting for questions to come in. Please do use the live chat feature in the platform to submit your question. So Kasey, do you want to quickly introduce yourself?
Sure. Hi, everyone. I'm Kasey Uhlenhuth. I'm a product manager on the machine learning team. So some of the stuff that I work on is the AutoML feature that you all saw that we released today, and then working on anything related to training and experiment management.
Awesome. Thanks, Kasey. And I lead the product team for data science and machine learning, which includes a lot of different components of Databricks and the Databricks machine learning product that we announced earlier today in the keynotes, and also that we walked through in the Databricks experience session. So with this, as mentioned, I see that there's a lot of you joining the session. Please don't be shy to ask questions in the live chat or the Q&A tool in the platform. One question that came up earlier, in the Databricks experience session, was about the forward-looking plans for AutoML, when we will support distributed training or time series forecasting. So Kasey, do you want to address that real quick?
Sure. So right now we focused on a single node approach for AutoML because many people are using scikit-learn models today, and we're kind of taking a productivity tool stance on it. And so for that, it's single node right now, but distributed training as well as sort of a distributed way of exploring your data with that data exploration notebook that we showed is definitely on our roadmap. And then time series forecasting as well. So that's one of the top things that we got when we were in private preview as a feature that we needed to incorporate and support. And so again, that's also on our roadmap, is to do time series forecasting support. We'll probably start with univariate and then go to multivariate for that.
Awesome. That's definitely exciting. And so with any of these updates, by the way, because Databricks is cloud service, you can of course always go check back on the AutoML product and see if you find new features. But of course, we will update customers with our release notes and blog posts from time to time. So another question that came up in the earlier session was around the different deployment modes that Databricks supports. And the key aspect to mention there is that Databricks machine learning and the model registry store all of the ML models in the MLflow model format, which means it's an open format that supports all of the ML frameworks and has a rich set of deployment tools built in that in a lot of cases are contributed by the open source community. So once you have a model in the model registry, you have any and all of the deployment options available to you from batch scoring. So in my talk, you saw the one line of code that you need to apply an MLflow model as a Spark PDF, to all of the integrations with the online model deployment services, and in each one of the clouds, like Azure ML, AWS SageMaker, and Google Cloud AI Platform, support deploying models in the MLflow model format. And of course, Databricks also has, we have our own built-in model serving tool that is in the model registry. So if you go into the model registry and click on serving, you can actually enable serving and expose the model as a REST endpoint and inference it at low latency. And then of course, there's a lot of other open source tools to deploy these models. There's also an easy one-liner using the MLflow CLI to package up an MLflow model as a Docker container to deploy it on a Kubernetes cluster, let's say. Awesome. So as mentioned, we see that we have a lot of participants in the session, and we're monitoring the live chat and the Q&A. So please don't feel shy to mention, to ask any questions in the online chat and in the Q&A session itself. Until we get some of these questions in, Kasey, did you have anything you wanted to cover about your own product portfolio, anything you're curious about, any of the other machine learning products?
You mean in terms of what am I interested to learn about how people are doing machine learning, or what do you want me to talk about?
Anything you wanted to mention about your product portfolio, or any questions you think the audience may have about the features or any of the other tools?
Yeah, so some of the other stuff that we've shipped, what you'll see as part of the new Databricks machine learning experience that we have, there's going to be a new experiments tab is something that we added, where now instead of having to hunt through the workspace to find your experiments, we now have this list view of experiments where you can easily find and discover not only your teammates' experiments, but also your own. So you can quickly find those. So would love to hear your all's thoughts eventually on that new experience that we've shipped. And then, yeah, if you have any new thoughts on the navigation experience that we have in general of navigating between SQL, the SQL experience and machine learning.
Yeah, that's actually a very good point. So we've had MLflow experiments, of course, in Databricks for a while. But the new experiment page that is part of the Databricks machine learning launch is brand new. And actually a lot of the users that had early access to it gave us feedback that it felt very natural to them. They basically said like it's as if it's always been there, and like that's a very natural way for them to discover and use their experiments. All right, we have one question coming in about AutoML and its support for natural language use cases and whether it integrates with pre-trained models. Kasey?
Yeah, so for NLP, that's something that we're hearing more and more. So it's on our roadmap to have text feature support. And so would be curious to learn what exactly are your NLP use cases. So in terms of that, we have to figure out, like, are we going to support UTF-8? Is it just English? What featurization do we need to do automatically for users? So that's what we're investigating right now. So we'd love to learn more about your use case there. And then in terms of pre-trained models, we do not yet do anything with pre-trained models, but that is something we're definitely considering as we move forward.
Yeah, a good thing to add there, by the way, is because of the unique aspect of our AutoML product, which is that we actually generate native code and make it available to you, is you could use AutoML to generate these models and then augment it with a pre-training model yourself, right? You have the flexibility because we provide you with the code. But yeah, a lot of these aspects about doing transfer learning and using some of the pre-trained models specifically in machine perception and natural language are all in the future things that we will extend the product with. All right, then there's another question. Is there a way to integrate on-premise feature store with the newly announced feature store? So that's a very nuanced, it's a good question that has a very nuanced answer. So the feature store that we just launched in Databricks machine learning consists of different components. The feature tables themselves that are written and stored in the feature store are in the Delta Lake format that is written to your own cloud storage, right? So if you write a feature table, really it's written in the Delta Lake format, which is based in Parquet, and then you can access that directly. So in theory, that data can be written to on-prem storage if you wanted to. It's an interesting interaction though, because one part is the data that is written in the feature store, and the other part is the metadata that the feature store stores about that data, right? So what is the name of the feature table, the feature names, the schema, who created them, integration with Databricks to tell you what code produced that feature table. And because Databricks is cloud only and cloud native, we don't provide an on-premise version of that server component, if you will, of the feature store. So you could achieve situations where maybe your data is stored on-prem, but the feature store service itself lives in Databricks in the cloud. What is certainly possible is the online portion of the feature store works in a way that you publish your features into an operational database. So the way that it works most of the time is that you have an operational database that you use for your low latency model deployment. That can be anything from Aurora MySQL to Redis to DynamoDB, anything that you can think of. And that is a pluggable interface in our feature store. So you can certainly publish features to an operational database that lives on-prem. Also, that's certainly possible. All right, let's go through some of the other questions in here. So we just answered this one. Let me just mark that as answered. For NLP applications, any plan to integrate with Microsoft's GPT-3 for generative sentiment analysis? Kasey?
So in terms of AutoML integration with this, we're still like in the nascent stages of exploring NLP use cases and how we can support that. I will say though that we are investigating, like, are there ways that we can sort of provide reference solutions or like starting points for things like this? So like, is there a way that we can give like provide more like transfer learning scenarios for people to quickly iterate on to get started in projects and things like that, which is kind of along the lines of this. So it's definitely something that we're looking into, but again, it's like we're going to have to take more of we think we'll have to take more of an industry or vertical approach if we do that. And so just trying to figure out what that looks like.
Yeah, and just to add to this, and I'm also adding this as a response to the question in the Q&A tool. We do have what we call Databricks solution accelerators, which are like pre-built solutions built on Databricks for specific use cases such as sentiment analysis. I don't believe we're using GPT-3 just yet for this, but you will find these solution accelerators that utilize all of the machine learning capabilities on Databricks specifically for some of these use cases. All right, let's see. So there's another question here. Hi, Kasey and Clemens, may I ask, what's your experience working as a product manager in Databricks? Could you elaborate a bit more on your day-to-day work? Thank you. So I would call that like slightly out of scope of the session specifically on machine learning, although the session is called Ask Me Anything. What I would suggest, Willon, is to like you can most certainly reach out to like Kasey and me directly, like find us on LinkedIn, and we can talk you through that experience. Another question from Munsu on does Databricks machine learning provide traffic split or shadowing when serving deploying models? That's an excellent question. So right now, the serving product on Databricks is a one-click deploy of the model. Right? So if you click deploy model as a REST endpoint, we bring up a cluster, load the model into memory, and expose it as a REST endpoint. Now, that is a very basic but powerful capability that a lot of our customers are already utilizing for a lot of use cases. As you may imagine, on the longer term roadmap for that capability are all of the aspects about a production grade serving product that you would expect, such as like guarantees for a higher availability, guarantees for like more low latency serving, or automated scaling to arbitrary workloads, right? And on that roadmap, as we're hardening that offering and enabling larger scale serving workloads, we will also address things like A/B testing or shared deployments that you would expect from these products. So long story short, like to answer very briefly, right now, you would basically rely on an external tool to split traffic. And you can still, of course, send the traffic to models that are deployed on Databricks. In the future, a capability like this will be integrated in our serving product itself. All right, let me go through some of these questions and hide the ones that we've already answered. Hello, Gaurav. Python, is there a Python API for the feature store that can be used outside of Databricks to access the online store? Yes, most certainly. So just to clarify the question also for the broad audience, as mentioned, the feature store has two ways of accessing features. One is through batch, which is for training and batch scoring. The other one is online. And the online pattern, the way it works is it publishes features to an operational database, such as a MySQL database. So there's two ways of reading those features from the database. One of them is there is an API, a Python client to look up these features from the online store, which is actually the way that we recommend you extract those features, because that API allows us to track feature consumers, right? So like you saw in the keynote, that we actually for each feature track who is using features from a feature table. And that's a really important like governance and lineage tool. Of course, because it's just a database that you own, you could also go and read the content of the database directly, right? So like if it's a MySQL database, you can just connect to it and read the content of those tables directly. But as mentioned, the recommended way, of course, is to use the Python client APIs. All right, let's go down the list. does AutoML support cost-based limitations instead of time-based limitations? And does it support spot instance usage? Kasey?
Right. Okay, so for the cost-based limitations, so this is where we're trying to figure out like what are people truly trying to do. And so that's why we did the time abstraction layer first, where it was a lot of people say, hey, there's a certain amount of time that I want this to run for because I'm trying to get a quick answer. And so that was like the sort of abstracted away restriction, whereas some people like to say, well, I want to restrict which models it can train over, et cetera. But at the end of the day, it kept coming down to the reason they wanted all these restrictions was because of the time that it was taking. And so right now you can sort of control for cost by which cluster you choose to train on in that cluster configuration, and then the time limit that you set. But we don't have a specific like train me the best model you can and $10 kind of thing. But it's definitely something that we're, trying to figure out what the price sensitivities are of customers and if that's a direction we need to go towards, or if having a time limit and you choosing your own cluster compute is sufficient there.
Yeah. And by the way, in the meantime, it's not right now. It's not being made explicit, right? So you can't say I want to spend $55 on this model. Right. But the cost is really a function of time that you use your compute resource, right? So like the first step in AutoML is you pick a cluster, right? And that cluster incurs cost, and like that is indicated by how many DBUs the cluster consumes. And basically, the time that you configure AutoML to use that cluster is like how much cost like AutoML will incur, right? Because like you're basically occupying that cluster for that amount of time. So it's an implicit way of being able to tell roughly the cost. But yeah, that's a really good point.
Yep. And we allow you to cancel in the middle of training too. So if you want to stop training at any point, you can cancel it, and then we'll stop using compute. Okay. So
yeah, good point. All right. Have either of you seen any demand for distributed training with AutoML, given that Databricks already have distributed compute available so easily?
Yeah, so we kind of touched on this in the beginning. Right now, we're focusing on single node training. We're basically parallelizing trials across the worker nodes, but all the questions disappeared. Okay, but yes, it's something that we are considering on our roadmap but the approach we'll probably take is doing more distributed exploratory data analysis. Like you saw in that exploration notebook, it's probably the first approach that we'll take, and then we'll look into doing distributed training and making sure that we have the full demand there or fully investing. But yes, it's something that we've heard from people that they want and expect.
Awesome. Yeah, sorry, I was hiding the question while you were answering it. Awesome. So Riley asks, can I create feature store features on existing Parquet sources in Databricks, or do they have to be in Delta format? Complicated answer maybe. So the feature store basically consists of the physical materialization of your features and the metadata in the feature store. You can actually create a feature table in the feature store for any type of data, right? Like you can declare a function and like declare this function to be a function that produces a specific feature table, and then it will show up in the feature store. However, all of the APIs that you will use to actually write that feature table to the feature store and then read it will materialize it as a Delta table. Now, that means if you already have existing Parquet sources or any other data sources, right? Like for that matter, you can have CSV files lying around. You can certainly read them, and the function that computes these features, you can add to the feature store. As soon as you write those features to the feature store, they will be materialized as a Delta table inside the feature store. Now, what that means is that, of course, as with everything in Databricks, the data source can be anything, right? You can read data in any format from any source. The feature store itself internally stores the data as a Delta table, but then on the read side, of course, again, you can read it as a Delta table and like read it into a Spark data frame. But of course, you can also read it in a Pandas data frame. Or if you train a TensorFlow model or a PyTorch model, you can read it into a TensorFlow dataset or a PyTorch data loader, I think is what those APIs are called. So really for all practical purposes, Delta, like the Delta format is like an implementation detail, if you will, of the feature store. But on the input and output side, of course, you can read and write in any format that you may choose. Awesome. All right. So it looks like we may have exhausted all of the questions, at least that came up immediately. So in the meantime, let's see if I can remember some of the questions that came up in the session earlier. So we already talked about the feature store. Is there anything else, Kasey, that you have top of mind that is like a frequently asked question?
I think like the distributed training is the main one for AutoML and transfer learning stuff, which we already did.
What about auto logging? Are we doing anything about auto logging on Databricks?
Oh, I mean, you showed that in your demo, right?
I don't think I did.
Oh, you didn't. Yeah, so we have a question on the roadmap of feature store, but I can just briefly talk about auto logging. So as part of the MLflow API, we have a feature called auto logging, where essentially it will basically automatically log a bunch of metrics and parameters for you, because what ends up happening is you end up writing code, and then a ton of your training code becomes instrumentation logging for MLflow. And so auto logging helps abstract away most of that. So then if you just have custom metrics, you only have to write the MLflow lines for that. And then we're working on a no code auto logging experience, where it's basically a cluster configuration setting, and we'll automatically do all that auto logging for you. And so this is especially helpful for new teams who are trying to learn MLflow, or for teams who have old projects that aren't connected to MLflow today, but they want new iterations to start logging. And so now if you hook up to these clusters with this no code auto logging enabled, you will be able to have all your metrics and parameters tracked, so that you're able to use the Databricks UI to compare trial runs and make decisions, then register your model to the registry.
Awesome. Yeah, and I love this feature, and I actually call it auto logging. Because we auto log as much information as we can without you even telling us that you want us to auto log it. So there is a question about a link to share about transfer learning. There is actually a blog that we published on transfer learning. I'm going to try to find it in parallel, and if I find it in time, I'll add it as a response. And then there's another question about the roadmap of feature store. So the feature store, as it launched today, is fully featured, pun intended, in terms of being able for you to track your feature tables, use them at batch, and use them online. There's a couple of items that we're actively working on to even simplify further the use of the feature store. One of the big ones is right now, if you wanted to keep a feature table up to date regularly, right? So let's say you have a feature table that you want to keep up to date daily. On Databricks, we have a job service that allows you to schedule a notebook as a job and set a schedule on which to run it, right? So you would basically set up a job that says run daily and update that feature table every day. Now, you can easily do that, and that's a manual process. However, we want to simplify it even further. So the feature store will actually both give you an indication in the UI of how fresh a feature table is. So if it's already being updated regularly, we'll tell you that this feature table is updated and on what cadence it's being updated. But then further down the road, we will actually give you an easy way of declaring, I want this feature table to be up to date at a specific cadence. And then we will update it for you, and we will manage all of the scheduling for you. So that's one of the aspects of even more simplifying things like keeping these feature tables up to date for you. And of course, there's many more investment areas that we're making in the feature store. All right, let's see. There's a question. Do you think it's within scope of responsibilities for data scientists? Oh, this question already sounds very exciting. Do you think it's within the scope of responsibilities for data scientists to understand the underlying infrastructure they built their models on? How does Databricks machine learning help with this? So that's a very philosophical question, and I think there's different schools of thought, if you will, on this topic. there's actually like a large group of data scientists that want to understand the underlying infrastructure because they just want to be very familiar with exactly how things work. And they want visibility so that they feel in control. And then there's of course like also a growing number of people that basically like don't want to have anything to do with infrastructure, and they just want things to work. On Databricks, we take the position that we want to serve all kinds of these users and give you the ability to either not have to worry about that infrastructure. And a lot of the investments that we do specifically in Databricks machine learning go into that direction, right? So managing your compute, managing your environment, installing libraries, managing the deployment lifecycle of a model are all things that you shouldn't have to worry about, right? And like Databricks machine learning takes care of for you. However, if you want to, and like for that group of people who want control and visibility, you can. Like you can basically find all of the API surfaces to customize everything. We have API surfaces to integrate with CI/CD systems to automate a lot of these processes. So I think we really take a perspective of providing that visibility and flexibility if users demand it, but not requiring it of users to actually use Databricks machine learning, which I think is a very unique approach because there's other solutions that are at the extremes, right, where they don't give you any visibility into what's happening, very like opaque type systems. And then there's the other extreme where you have to be like a DevOps engineer or like an infrastructure engineer to actually understand what's going on. Sorry, maybe too long of an answer, but a very good question. All right, the next one is, I think of feature engineering as the art of data science. What sort of techniques does AutoML use to do feature engineering? What algorithms are used to test it in AutoML? Kasey?
Yeah, so this is like perhaps another philosophical question on how much feature engineering should an AutoML solution be doing, and what does require the domain expertise, where we should just be helping people do feature engineering and selection. And so the latter approach is what we're taking right now with AutoML. So right now we just do very basic feature engineering for you. So for example, like with timestamps, we'll help you with that sort of featureization. And then if we do support text features going forward, like we'll do like the bigrams and n-grams for you and things like that, where it's sort of like standard, very like basic feature engineering. However, a lot of people, well, not a lot, but like some people want AutoML to be sort of a brute force solution where they say, hey, come up with all possible combinations, test them all for me. And I consider that like AutoML taking away the burden of all this for me and just getting me the best possible model. And some people have that kind of approach. So we're kind of trying to toe the line here and like find the right balance on how much we should be automating versus helping. And I think sort of the way that we're thinking going forward is instead, we're just going to sort of maybe suggest features that you should be using and kind of have this more suggestion or recommendation approach, perhaps through a notebook, like we do with the training notebooks, to allow you to use your expertise again to augment your training, but then also kind of automating some of the more basic or tedious parts of feature engineering. And then of course, as we integrate with the feature store, you'll be able to like augment your data set with those features for feature selection as well.
Awesome. All right, so I know we're coming up to time. So there's one question that I'm going to answer here real quick, and then maybe just one more that we have time for. So this question is from Gautam. Any timeline on when model serving will be available for high throughput applications? Do we have any control over the cluster configuration used in serving? So the answer to the second question is yes. You can actually customize in Databricks serving what cluster configuration you want to use. That is important if you want a beefier cluster because you have a large model that you want to serve. And in the future, I believe, not today, but soon, you can also, of course, pick GPU instances if your model requires GPUs for inference. So you can already configure the type of instance that you use for serving. It will always be a single node instance though, because it doesn't actually like launch a cluster with a driver and multiple workers, but it launches a single driver only, if you will, cluster that loads the models into memory. And then the first part of the question is any timeline on when serving will be available for high throughput applications. So that really depends on the definition of high throughput. The current solution, and I think we have that in our documentation, will go up to 30 QPS, which actually is sufficient for a lot of applications. So we have a large number of customers that use the current serving product for their serving use cases because like they are below 30 QPS and it works just fine. So we will be making incremental improvements to this product over time and like relax some of these constraints and like open it up to bigger workloads. But there will be a big step function most likely later this year. Definitely watch out for announcements from us on this. All right, I think that was
There's one more real quick on sorting models by multiple metrics in the table. Yeah. We don't allow you to do that. We are looking into maybe improving the UX and UI around that table. But for now, sorry, as a workaround, you can use the API to load it as a data frame.
You okay there?
Sorry, to load it as a data frame, and then you can do queries on that data frame however you want. So they can do it on that. Whew.
Yeah, that's a really good point. And by the way, that also underlines the flexibility that we provide. You can actually get to the metadata from ML flow in many different ways. There's Python APIs, there's REST APIs. There's a way to get it into a data frame. We actually on Databricks also have a Spark data source for the metadata and ML flow, because we have some customers that have millions of experiments and runs and models. It actually becomes a big data problem to manage all of the metadata, which is super interesting. All right, so I think we got to all of the questions. Thanks a lot to everyone who asked questions and engaged with us. I'm still going to follow up on that one question about transfer learning. I'm going to find that blog post, or I think maybe it was a webinar that we did on this, but I'm going to respond right after we close the session. So thanks everyone, and always feel free, of course, to reach out to like Databricks representatives or the product team if you have any other follow-up questions. Have a good rest of your day.